we discovered a signature for colorectal cancer patients that would inform the order of chemotherapy that they should take. And so going, chemo regimen A and then B, or B and then A, and getting the order right led to a 17-month increase in overall survival.
Welcome to UnNatural Selection, a show about competition, innovation, and the strategies shaping tomorrow's frontiers. I'm Nick Encina. Each week, we speak with pioneers shaping the future.
This is episode 9, produced in partnership with Mass General Brigham's World Medical Innovation Forum. Today, we're inside molecular diagnostics, where progress isn't measured in quarters, but in time gained or lost. Cancer care is evolving quickly, but not every breakthrough comes from a new drug. Sometimes the biggest gains come from knowing what to do first. In this episode, we explore how molecular profiling and AI are guiding treatment decisions, and how rethinking sequence, not invention, can dramatically change outcomes. Our guest is Dr. David Spetzler, bio verbatim. Dr. Spetzler joined Caris Life Sciences in August 2009 and has led R&D and laboratory operations in a multitude of roles. As president, he currently leads the company's clinical operations, research and development, information technology, bioinformatics, and biopharma services. Spetzler has generated more than 330 patent applications across more than 35 different patent families and co-authored more than 20 peer-reviewed journal articles. As an innovator in molecular science and precision medicine, Dr. Spetzler has a relentless focus on improving patient care. He has led the development of each of the Caris's clinical offerings, including the launch of clinical whole transcriptome sequencing in 2019 and whole exome sequencing in 2020. More recently, he led the launch of their first AI-based clinical products, and he also led the recent development and launch of a new whole exome and whole transcriptome liquid biopsy assay that sequences DNA and RNA from both plasma and buffy coat to provide sensitive testing to patients without requiring a tissue specimen. Let's go.
David, welcome to UnNatural Selection.
Thank you for having me.
I always start with the same question just to level set and kind of ground for the audience before we get started. Could you please let us know what business that you're in and what your role is within that business?
Sure. I'm in the business of trying to help people live longer, and we do that by helping cancer patients. I'm employed by Caris Life Sciences, and I'm the president of the company.
Excellent. And so for those that have never heard Caris Life Sciences, can you give us a quick picture of what the company does and the problem you're trying to solve in healthcare?
Absolutely. So what we try to do is understand the molecular drivers behind disease, specifically starting with oncology and solid tumors. And so traditionally, what we've done is taken a piece of tissue from the tumor and looked at the molecular changes that cause that cell to go bad, understand the nature of that, and then try to guide patients towards particular therapies that are more likely to work and guide them away from therapies that will less likely to work. We've more recently taken that approach to the blood, where we're doing the same thing. And then with the blood, it creates an opportunity to start going earlier and earlier in the stage of disease, so that instead of just looking for, how do we treat cancer better? How do we find it earlier? And that leads to actually using the same molecular system to find a multitude of diseases, because the real goal of precision medicine should be precision prevention, where we identify cells going bad before they can actually become a symptomatic disease and take them out, maintaining kind of the health of the patient and the immune system, so that we're not fighting the symptoms, we're fighting the source early on.
That's excellent. As you were describing that, a bunch of questions came to mind, especially around prevention. I'm a big fan of that. I spend a lot of my time working in that field as well. And really thinking about the paradigm of how Caris innovates. There are so many different ways that you can actually innovate a product or a solution towards solving a real world situation like, cancer and other diseases. And the way I understand it, you're not just adding data to a cancer diagnosis, You're trying to rewire the decision-making process itself. Innovation can sometimes be about adding new capabilities to existing systems, but at other times it's about fundamental rethinking how the entire system operates. How does Caris balance incremental improvements versus reshaping the way oncology diagnostics works at a broader level, thinking about then the way that you segue this product into clinical care?
Yeah, well, we're pretty fortunate that those two things are tightly coupled together. So, as we make incremental improvements in how we interpret data and measure changes, um, that leads to massive insights. And so, 5 years ago, we made what was considered to be somewhat of a crazy decision to go to whole exome and whole transcriptome sequencing. At the time, people were measuring maybe 300 genes, 400 genes per patient, and we went to 23,000. And we did that because we looked into our database, and at that time, we were measuring 592 genes. And we discovered a signature for colorectal cancer patients that would inform the order of chemotherapy that they should take. And so going, chemo regimen A and then B, or B and then A, and getting the order right led to a 17-month increase in overall survival.
Wow.
And when we looked at the markers that we were evaluating, that were teaching us about that order, what we found was that about 60% of them weren't on anybody else's panel. And so we were like, wow, look at what we can do with this extra information. And yet we're only measuring 592 genes out of the 23,000. So it became clear at that moment that we needed to go much, much bigger, much broader. And so that was what motivated us to go after the entire exome and the entire transcriptome. Fast forward to today, where we have over 500,000 patients with that and about 5 years of longitudinal outcome data. We're finding more signatures that tell us what's going wrong and how it's going wrong. Because if you take a step back for a second and you think about the nature of disease, all disease are cells going wrong. And if the cell is going wrong, there's something in the molecular system that's driving that. And we now have the technology to measure those molecular systems. So when you start to think about, okay, how do we start to improve human health? Right? It's not just more treatments. It's really, we need less treatments. We need to find things early enough and diagnose them accurately and quickly so that we can minimize interventions. That's how we save the healthcare system massive amounts of money and prolong life. And so to do that, you need to measure everything that you possibly can on as many patients as you can, because the most precious thing in this entire value chain is actually the human sample that you're testing and learning from. And so if a sample comes in and you only measure 600 genes, well, that's a huge lost opportunity. If we measure everything, then we don't know what's going to matter today, but we won't find out what matters tomorrow if we're not making that investment today. And that's what we've done. That's the bet that we took. And so now what we can begin to see is there are a lot of different ways that cancer is making cells go wrong. And there's a lot of different ways that we can start to change that. And as you said, rewire the system to be able to be far more efficient. Because these chemotherapies and these targeted therapies, even the immunotherapies, that's not a cakewalk, right? That's hard on the patients. And so the less intervention we can do, the better, as so long as we're, maximizing life and quality of life at the same time.
That's excellent. And Caris combines a lot of scientific complexity, genomics, AI, diagnostics, but ultimately your impact depends on how easily that fits into the daily life of the oncologist. What's been the hardest part about making something this complex usable at the point of care?
Yeah, it takes a lot on the kind of the back end to reduce this to simple practice. And so we try to do that for the busy clinician. The report that we give back, we try to simplify it down to red is no, green is go. So, they may have 20 seconds to prepare before meeting with the patient. You know, they don't have time to go in and delve through the complexity of all the molecular aberrations that are driving the disease. but they do need to know, hey, these are good drugs, these are bad drugs. And so we can reduce that, when there's a very short amount of time for preparation. But then also it's our job to enable a much deeper review as well. And so, if you get to the point where it's past standard of care for the patient and it's time to really start to say, okay, what are we going to do next? We don't have any evidence guided rules to say how to treat this patient now. That's when you have to delve really deeply into the biology to say, okay, this pathway is messed up. Here are some drugs that attack that pathway. Let's go ahead and try that direction. That's third, fourth, fifth line treatment where there are no trials, there are no indications that allow us to know what to do. And so we have to extrapolate from our base knowledge of how these systems work together.
Hmm. And, we often think about innovation purely as technology, but care seems to be innovating across the board, from how you generate insights to how doctors and hospitals use them. Where do you see Caris creating value beyond just the technology itself? And how has that shaped your approach to long term competitive advantage?
Yeah, great question. So we have kind of a roadmap that we follow. So there's one thing that is creating data, right? Once you have data, the goal is to take that data and turn it into information. Once you have information, then you're hoping to turn that into knowledge. And once you have knowledge, you want to turn that into wisdom. And so that guiding principle really encompasses everything that we're trying to do. So, you measure as much data as you possibly can, and then you extract information from that. Once you have that information, then you can start building these signatures that give you the knowledge of what to do. And then the wisdom comes in being able to show clinicians that, in fact, that is the right thing to do and get them to act. And so that whole philosophy really encompasses how we think about, innovating. So it's got to be fast. It's got to be easy. It's got to be, something that is covered by insurance. We worked very, very hard to become covered by insurance so that this is attainable by the vast majority of people. And then it has to be something that is understandable enough that people can have confidence in it. And so, in addition to kind of that philosophical roadmap behind how we develop things, the most important guiding principle at Caris is what we call the mom rule. And the mom rule says, "Is this what you would want done for your mom?" Because this company was founded by a man named David Halbert who lost his mom to cancer. And so when he started Caris, it was with the principle of I want to build a company that would have done right by my mom. And so, that guiding principle is evident in everything that we do because we don't put cost first. It doesn't matter to us that, when we went to these much bigger assays, that it more than doubled the cost of goods. We didn't change our reimbursement at all, but we did something far more expensive because it's the right thing to do. It's what I wanted for my mom, and it's what everybody would want for their mom. And so when you couple that you know pathway of taking data all the way through to wisdom, and you couple that with you know what we need to do is figure out how to do right by the patient, that creates a very powerful toolbox and incentive for all of us to work harder to get better, and really make the world a better place. I mean, there are very few people that are lucky enough to say, I get to come into work every single day, invent things that help people live longer, and I'm lucky enough to be one of those people.
That's incredible. And it sounds like what you do is you project, if I can say back to you what I heard is you think about the patient and you work backwards from there, thinking about that experience to that person. How do we make their life better? And then what are the key steps in fulfilling that promise? Which sounds like there's a bunch of invisible stuff happening there. So Keras is obviously innovating on things that are obvious, like technological features and things like that. But then there are probably less visible, but equally powerful areas that you're innovating in, like service, brand, customer engagement, and other things that shape the solution, not just a technological tool.
Absolutely. So, every time one of our tests is ordered, we reach out to the patient to let them know what this is going to look like when insurance starts sending them information, because they'll get what's called an explanation of benefits, which is not a bill. And so warning them that, hey, you're going to get this documentation. That's not a bill. You don't need to worry about that. That's your insurance company explaining to you, you know, the value of the benefit of the service that you're getting. This is not something that is going to generate financial toxicity for you. And we get to work with them and warn them because, I mean, dealing with cancer is hard enough. Navigating the healthcare system, that's almost equally as bad in some cases. I mean, it is not easy. And so, we want to set up a system, and we have set up a system where we're supporting patients and where they can understand that, hey, you just got a whole new team member that's here to help you and back you up. Because our job does not end when we deliver a report to the physician. So one of the advantages of having whole exome, whole transcriptome is, let's say there's a new drug that's approved tomorrow on a new biomarker that nobody has ever heard of before. Well, it's already in our panel. We've been testing it for the last 5 years. So what we do is we go into our database, we identify all the patients that would be eligible for this new drug, and we reach back out to their physicians and say, hey, you remember Jane Doe from 9 months ago? Guess what? Here's a new drug that she's eligible for. You may want to check this out.
Mm.
So this is an ongoing relationship for us. We want to help people for as long as we can.
Yeah, that's I can definitely see the value to an oncologist there because you become a value-added partner long term. You're not just like a point of care; it's more like a decision support tool that just keeps giving, and monitoring developments to the science, along with helping at point of care. So I guess it takes me to the next question. Um, there are a lot of companies trying to do something in precision oncology space. It's obviously a very fiercely competitive space. And I think you've shared some of this already, but really just to make it concrete, what are Caris's core competitive advantages, and how do you defend that as the field gets more crowded?
Yeah, it's actually pretty easy for us. We don't think that there's very much competition, honestly, because there isn't anybody else that made that decision 5 years ago to go big. And so when you think about what does it take to develop a new signature, and we've got them coming out all the time, you need the molecular data, but then you need longitudinal clinical outcome data. So if you're changing a patient's survival by 1 year, 2 years, well, that means that you need to be collecting outcome data for probably 3 or 4 or 5 years. And so we're so far ahead of everybody else in our accumulation of data that they're they're not competing with us. We're not doing the same thing. They are, selling a small test to try and give information for today, whereas we've been gathering information to try and change the world forever. And so, um, once our clinicians and our partners understand that, then there really is no competition. Because another big part of this is, you know, we're good at the science, we're good at the technology. We need the partnership of the clinicians in order to make that step from information to knowledge. So, we've created what we call the Precision Oncology Alliance. That's an academic industrial collaboration where we've got 97 institutions around the world where all of those members have access to this enormous data set that we've compiled so that we can advance the science and the medicine. Because this is going to take a village. This is way bigger than one company, one institution. For us to start to really make the inroads that we need the world's greatest minds all working together hand in hand. And so, that is very unique to us because we're not a vendor. We truly are a partner, not just in the clinical care, but in advancing the science. And so we crossed our 1,000 publication mark last year,
Hmm.
um, all done in collaboration with great institutions like MGH, for example.
That's amazing. Congratulations. When you think about competition, you're not just competing against other companies, you're competing against inertia in the system as well. What have you learned about
Competing
getting?
against cancer. That's what we're competing against.
No, I love that. I live downstream on the implementation side, and I know how hard it is to get things into health systems. Um, And so from that, what have you learned about getting new diagnostic approaches adopted at scale in healthcare?
So EHR integration is absolutely essential. So if you're asking somebody to leave their EHR system to order a test through some other portal and then go and look for results somewhere else, that's a lot of extra work that's outside of the routine. That creates a lot of inefficiency. The very best systems are those that have integrated both ordering and results directly in the EHR. And then a lot of systems now have identified, okay, these are the patient characteristics of somebody that they think should be profiled. And so there's an alert that pops up that reminds the physician, hey, this is the time you need to order this test now. And so streamlining the workflow, making sure that they're doing what they want to do, just makes everything easier for everyone else. And we don't dictate, hey, this is when you should order. That's their decision. That's a clinical decision and it's patient specific. But a lot of these institutions, they know that they can define, hey, we want to make sure that we're profiling every single non-small cell lung cancer that's stage 3B or above, within 5 days of diagnosis or within 5 days of recurrence or progression. And so they create the rules, and have then built in those systems within their own EHR system to be able to make sure that there's a high level of compliance. Because the saddest thing really is that it's only about 30% of patients that are getting comprehensive genomic profiling today that should. And that means that 70% of metastatic cancer patients aren't getting the opportunities to get some of these better treatments. And it's not because insurance doesn't pay for it. It's because this is new stuff. And we need to help physicians know what to do. I mean, the average age of an oncologist in our country today is about 54 years old, which means that when they went through medical school, they weren't taking a genetics class and a molecular biology class. So they've had to learn this all along the way, and it's complicated stuff. So it's incumbent upon us to ease that burden, to make this something that they understand, can trust, and act upon. And to that end, we have a field force of about 55 PhDs whose sole job it is to help translate the world of genetics and molecular biology to the clinicians so that they can know and understand exactly what it is we're saying and know what to do for their patient.
That's amazing. And as you mentioned some things there. So as cancer care becomes more data driven, what do you think the role of the oncologist looks like over the next 5 or 10 years? What does the oncologist of the future look like? Like you said, the average age of the oncologist, I think you said was 54, 55. So what does the oncologist look like with your technology over the next decade or so?
Yeah. So, in the beginning, we kind of said, okay, here's colon cancer, here's breast cancer, here's lung cancer. And now we say, okay, here's non-small cell lung cancer that's EGFR positive. Here's non-small cell lung cancer that's PD-L1 positive. And so there's this hyper segmentation of patient populations, and there are many, many, many populations out there. And so, for some of the populations, we know exactly what to do. For other populations, we don't know what to do. And so we can only define the populations based upon, the relevant insights. And so a big part of where oncology is going is in defining these new patient populations. And that's going to be a big part of what oncologists are doing is, okay, hey, here's my non-small cell lung cancer patient that's EGFR positive, but they didn't respond to a TKI. Now that's a new population that we need to study. And then they'll further enhance and say, oh, and you know, they were experiencing neuropathy as well. And so there's so much information gathering that needs to happen that can only happen on that front line, where you have, people that understand, kind of the clinical attributes of a patient that are necessary to define these subpopulations that we can then go in and say, okay, now we know about this population. Let's start to study their genetics. What's driving their tumor, because maybe we can then understand what that is. So, I see I see oncologists kind of leading the charge in defining the areas where we need to go in and say, okay, let's try and answer this question about this subpopulation. Because if you look at it at a population level, then we're doing a disservice to most people.
Mhm. And you've been so generous with your time. So in the interest of um, looping back to maybe some of what you said in the beginning behind the mission of the organization and how it was founded and what drives you every day, which is making patient care better and making better decisions by mom. One last question, Dr. Spetzler. The field of precision oncology is evolving rapidly with the potential to radically change how we diagnose and treat cancer. So, looking ahead, what do you see as the most transformative shifts on the horizon, and how do you believe those innovations will shape the future of human health on a global scale?
That's a great question. So we've been spending quite a bit of time looking at patients that don't have cancer, comparing them to those that do in order to be able to diagnose cancer from the blood earlier. And one of the things that we found is that we can identify pathogenic mutations in the blood that nobody has ever seen before. And we've done that by taking our tissue database of 500,000 patients and building an AI to identify these pathogenic mutations. And if you look in the databases that are public, they're identifying about 15,000 different pathogenic mutations. Uh, we're over 900,000 pathogenic mutations that we've identified. And so what that means is that we can find these mutations in people that don't have disease yet. And there are lots of therapeutic modalities to target those mutations. So, you know, peptide based immunotherapy, much like the flu vaccine is, mRNA, much like the COVID vaccine is. So, we have the technology to go after these bad acting cells and take them out before they turn into something that is bad for patients. And that's precision prevention. So that's, you know, we're skating to where that puck is going to be, because that's where I think we'll evolve to in terms of a healthcare system. Because then all of a sudden you go to this place where, okay, we're all just taking a blood test every year, finding out, oh, we got a little bit going on here. You know, here's your shot, and it takes care of it. And all of a sudden, you know, the rate of chronic disease is going to plummet. And it's not just cancer; it's all sorts of different chronic diseases will be handled by that approach.
That's
So that's the big idea that is the future of precision medicine, in my opinion.
I love it, and I can't wait to see it. As you may know, I'm downstream at the point of care where precision medicine is reaching newborn sequencing and newborn screening, and so we often look to the specialty care areas to see what they've done upstream, so then we can potentially bridge some of that down to population levels. And so, congratulations on all of your accomplishments. Thank you for what you're doing for the field, and thank you very much for your time today. I look forward to meeting you, hopefully in person, at the World Medical Innovation Forum later this year.
Thank you very much. I look forward to it as well.
That was Dr. David Spetzler. Now, unnatural signals.
This conversation reminds us that innovation doesn't always mean something new. It often means something used differently. Here's what we're archiving. Sequence matters. Choosing when to apply a therapy can be as powerful as the therapy itself. The real opponent is inertia. In complex systems like healthcare, progress depends on making new insights usable, trusted, and easy to act on. The future is prevention, not reaction. The biggest shift is moving upstream, finding problems years before symptoms appear. This is what evolution looks like when the goal isn't disruption, but precision.
Thanks for listening to UnNatural Selection. If you enjoyed the episode, subscribe, leave a review, and share it with someone shaping the future. Explore more at unnaturalselection.net and connect with us on LinkedIn and Facebook. Until next time, keep evolving.